Now, last page is going to kind of put all these pieces together and help us find the domain of more complex functions. So, for example, let's start with a basic polynomial. Last year, you guys studied the domain of polynomial functions. When you're looking for the domain, you know the domain is going to be all real numbers except for something. These exceptions are going to be what makes the function undefined. Well, with any polynomial function, there is no x value you can plug in here where you will not get an output. The domain is simply going to be all real numbers, so it's going to be negative infinity to infinity. Now, when you look at number 2, your rational function, remember, anytime you have a fraction, a 0 in the denominator is going to make the function undefined. So you're trying to find the domain of a rational function, it's going to be all real numbers, except where the denominator equals 0. So in this particular case, when you set x minus 7 equal to 0, you end up with 7. So I know that the domain is going to be all real numbers except for 7. So in interval notation, it's going to be all real numbers less than 7, and then all real numbers greater than 7. So you have to write 2 intervals when you're excluding one number from the domain. When you have a square root function, remember, if you have a negative number underneath of a radical underneath of your square root, that will put you in the imaginary number system. We want to be in the real number system. So to figure out what the domain of any square root function is going to be, you're simply going to take whatever's underneath the square root and you make it greater than or equal to 0 and solve. So again, going back to algebra 1, you can subtract 1 and divide by 3. So x has to be greater than or equal to negative 1/3. So in interval notation, I'm going to bracket negative 1/3 to infinity. If you look at number 4, you have another square root function. Again, you cannot have a negative number underneath the square root and remain in the real number system. So I'm going to take x squared minus 2x minus 15, make it greater than or equal to 0. This is what we just got done talking about at the very beginning of the lesson. You have a 0 on the right-hand side. This is a quadratic. You need to find your critical numbers and do your number line test. So to find your critical numbers, I'm going to have to factor x squared minus 2x minus 15. This will factor into x minus 5 times x plus 3 greater than or equal to 0. So my critical numbers are going to come from 5 and negative 3. So again, when I do my number line test, I have negative 3 and 5. I can include them because I can take the square root of 0, so it's greater than or equal to 0, and do my number line test. A number less than negative 3 is negative 4. Negative 4 minus 5 is a negative. Negative 4 plus 3 is a negative. And a negative times a negative is a positive. So I know I will have solutions less than or equal to negative 3. Plug in 0. 0 minus 5 is negative. 0 plus 3 is a positive. This will be a negative answer. Plug in 6. 6 minus 5 is positive. 6 plus 3 is positive. So my solutions will be all real numbers greater than or equal to 5 as well. So my domain then of this function is going to be negative infinity to negative 3, and then 5 to infinity. So again, number 5, you have a square root function again. Again, you have to make sure you have a positive number or 0 underneath the square root. So I have to take 7 minus x over 3x minus 2 and make it greater than or equal to 0. Remember, when you have a rational inequality, you find the critical numbers by setting the numerator equal to 0 and the denominator. So my critical numbers are going to be 7 and 2/3. Again, if I do my number line test, there's 2/3, there's 7. Again, any critical number, remember, that comes from the denominator cannot be included. So that 2/3 is not going to be included in my solution set. However, I can be equal to 0. Being equal to 0 comes from setting the numerator equal to 0. So I can put a closed circle above 7. A number less than 2/3, I can plug in 0. 7 minus 0 is a positive number. 3 times 0 is 0, minus 2 is a negative number. So numbers less than 2/3 will give me a negative number. A number between 2/3 and 7, I can check once. 7 minus 1 is positive in the numerator. 3 times 1 minus 2 is positive in the denominator. So I do have positive numbers between 2/3 and 7. So I'm going to have solutions. And then finally 8. 7 minus 8 is negative. 3 times 8 minus 2 is positive. So I'll have negative numbers greater than or equal to 7. So then the domain of this particular function is going to be 2/3 to 7 inclusive. You guys go ahead and try number 6 for me on your own.